Okay, today we're going to start learning about the topic of stoichiometry. All right, so we've kind of gotten to this point. We can write chemical formulas, we can write chemical equations, we can balance chemical reactions now. So now we've come to the final point. So with the balanced chemical reaction, let's kind of think of some stuff that's telling me. So here's a reaction between magnesium and oxygen. So if we break this down, what's really telling me is two atoms of magnesium react with one molecule of O2 to produce two molecules of MgO. Okay? Or in other words, as we've been balancing it, the coefficients, or as some of you like to say, the big numbers in front of our chemicals tell me the ratio in which the chemicals react. Okay, they tell me a ratio in which the chemicals react. It's kind of like a recipe, so if you think of, think you're making a cake or something like that. And let's say for this particular cake recipe, it calls for 2 cups of flour and 1 egg. Okay, well, to make the cake right, you'd want to put 2 cups of flour and 1 egg in. If you were to put 4 cups of flour and 1 egg in, you wouldn't have a very good cake. Or if you put, 3 eggs in and 1 cup of flour, your cake wouldn't come out. Okay, the same thing is true with chemistry. Okay, so these numbers in front, all right, these coefficients tell me the ratio in which those chemicals need to be in order to react. Okay, it doesn't mean that you can't have more. You could have 4 magnesiums and 1 oxygen, but you only have 1 oxygen, so that would determine how much you make. But we'll talk about that later. So now with chemistry, though, let's think of what we have. So they're happening on the smallest level. Okay, this reaction is going on an atom-to-atom basis. So if you break everything down to the smallest ratio, the reaction occurs on an atom-to-atom basis. But when we see the reaction, we're not seeing it on an atomic level, right? If you actually see this reaction, and when I get back into class next week, I could show you this reaction. It's pretty easy to do. We can see this, we can observe it, but we're seeing a lot more than 2 atoms of magnesium reacting with 1 molecule of O2. Okay, we're seeing moles, right? So if we remember about atom-atom basis, we have this unit called moles. And what is moles? Moles is a way to count really large numbers of items. And why do we use it in chemistry? Because it happens on an atom-to-atom basis. Okay? Back to this balanced chemical reaction. 2 of these need to react with 1 O2. Okay, so I need to know how many, not how much. This doesn't say 2 grams of magnesium needs to react with 1 gram of oxygen. It's 2 moles of magnesium need to react with 1 gram of oxygen. Okay, so what we're going to do here is we're going to compare these through moles. So our coefficients at the front of the balanced chemical reaction, okay, are also called mole ratios. Okay, it tells me the ratio that the chemicals react to. So going back to this equation, 2 moles, another way to say this is 2 moles of magnesium react with 1 mole of oxygen to produce 2 moles of magnesium oxide. Okay, so your balanced chemical equation gives us those mole ratios. So now we can start kind of multiplying and changing stuff. What if I had 4 moles of magnesium? Well, then I need what? I need 2 moles of oxygen, and then I'd produce 4 moles of magnesium oxide. Let's do another chemical reaction down here. Let me write one real quick. Let's say I have sodium chloride, and I react it with some fluorine to produce some sodium fluoride plus chlorine. So it looks like a single displacement here. Now, critical step before we start talking about stoichiometry and mole ratios, we have to balance this chemical reaction. I have 1 chlorine on this side, on the left side. I have 2 chlorines on the right side, 2 fluorines on the left, 1 fluorine on the right. So if I want to balance this reaction, it's going to look something like this. So now we have a balanced chemical reaction, so we can start talking about mole ratios. My chair just broke. Mole ratios. So 2 moles of sodium chloride react with 1 mole of fluorine to produce 2 moles of sodium fluoride plus 1 mole of chlorine. Let's do an example question here, like real quick. How many moles of fluorine would you need to react with 6 moles of NaCl? Okay, so now we just go back. We still have our ratio. We know it's a 2-to-1 ratio. There's 2 moles of sodium chloride per every 1 mole of fluorine. So we can go down here and use that ratio to solve this. If I have 6 moles of sodium chloride, I know my ratio is 1 mole of F2 per every 2 moles of NaCl, and that the moles of NaCl cancel out based on this ratio, how we have it set up here. And what do I find out? I need 3 moles of F2. Okay, so ratio, you guys are really comfortable with ratios. You've used them a lot. The critical thing with this is just balancing my chemical reaction, and then as soon as I balance a chemical reaction, I can convert from 1 mole of a chemical to a mole of any other chemical. You know, if this same question said, well, how many moles of NaF, sodium fluoride, could be or would be produced from 6 moles of sodium chloride, well, what would our answer be? Well, let's go look at our ratio. My ratio tells me that for every 2 moles of sodium chloride, I get 2 moles of sodium fluoride. Or it's a 1-to-1 ratio, right? I get equal amounts. For every 2 of these, I get 2 of these. So in this case, if I had 6 moles of sodium chloride, I would get 6 moles of NaF. Or if you wanted to write it as a ratio, it'd be 6 moles of NaCl. Okay, that's our number we're given. Then my ratio for my balanced chemical reaction, 2 moles of NaF per every 2 moles of NaCl. And I would put NaCl on the bottom because I want to cancel that out, just like we've been doing all year with dimensional analysis. 6 times 2 divided by 2 is equal to 6 moles NaF. All right, so mole ratios. From our balanced chemical equation, the coefficients at the front of chemical equations tell me my mole ratios, right? So that what that allows me to do is determine the moles of every chemical I have. So mole ratios, the mole ratios allow me to determine the number of moles for each chemical compound in the reaction. Okay, so that's what we'll start with today. So what I'm going to do is I'm going to give you a couple practice problems working with mole ratios like this, and also I'm going to give you some problems where we're converting from moles to grams and grams to moles. We haven't done that in a while, but that's going to be kind of our next step here. All right, there we go. Hope you guys have a great day today.